Good morning all, my name is Santhosh Kumar, Assistant Professor, Institute of Aeronautical Engineering. My subject is image processing. Today I am discussing about region-based segmentation. So, region-based segmentation, this approach consists of partitioning an image into regions that are similar according to a certain set of criteria. The region-based segmentation technique involves an algorithm making segments by dividing an image into various components that have similar pixel characteristics. This technique searches for small or big chunks in an input image for segmentation purposes. It will either add more pixels to the selected chunks or further diminishes chunk points into smaller segments and merge them with the other smaller chunk points. Okay, so there are in the image segmentation. So what is the need of image segmentation means we have to go for the segmenting the image. So we are dividing into the segments. So there are so many types of image segmentations are there, but especially we are discussing about region-based segmentation. So what we are especially discussing about region-based segmentation, we'll discuss. So it is consist of partitioning an image into regions that are similar according to a certain set of criteria. The region-based segmentation technique involves an algorithm making segments by dividing an image into various components that have similar pixel characteristics. So, this technique searches for small or big chunks in an input image for segmentation purposes. It will either add more pixels to the selected chunks or further diminishes chunk points into smaller segments and merge them with other smaller chunk points. Okay, so here there are two or more basic techniques based on this method is a region growing and a region merging and splitting. So here I am taking input image, output image. So this input image has the region growing and region merging splitting. Here it is the gray level image. What is the color image? So it is a color image plus segmentations. Color image plus segmentations are there. So input is a grayscale. We are converting to the color with the segmentations. How we are finding out the segmentations means we can see here what is a cap and what are the backgrounds are there. How the nose is there. What are the colors are there. So each segment, each color are there. It is one segment. Color is red. Each segment, the color is like this. Okay. So this gray color image is converting to the color image with segments. So image segmentation techniques based on edge-based technique, region-based technique, threshold technique. So edge-based technique advantages works well when the edge is prominent, and region-based technique advantages better for noisy image where edges are hard to identify. And threshold technique, one of the best easier technique is there. So when we are going in the image segmentation, three types are there: edge-based technique, region-based technique, and thresholding technique. So when we are going for the edge-based technique, works well when the edge is prominent, and region-based technique is better for noise image where edges are hard to identify. And advantages of thresholding techniques are there, one of the best and easiest technique. But in the edge-based technique, what are the disadvantages? Could not be applied on images having many edges, not suitable for images having smooth edges. But when you are going for the region, the point must be specified. Different seed points may be given at different points. When you are going for the thresholding, could not be applied on image having complex intensity distribution like medical images, and cannot process the images whose histograms are nearly unlimited. So segmentation methods majorly two types, based on discontinuity and based on similarity. So based on discontinuity, edge-based technique, and based on similarity, threshold, region-based, spatial theory. So based on discontinuity, edge-based is there, and based on similarity, thresholding-based, region-based, and spatial theory. So in the spatial theory, neural network based, clustering based, and wavelet based. So in the spatial theory, neural, clustering, and wavelets. So these are about the segmentation method. Segmentation means we are segmenting the images. Segmenting the images. So based on discontinuity, based on similarity. So edge based technique is one type of discontinuity, and based on similarity, thresholding, region based spatial theory. In the spatial theory, neural network, clustering based, wavelet based. So in the region based so in the region based segmentation, we are converting to the segments. So in the segments, discontinuity and continuity. So in the discontinuity, edge based, in the continuity or similarity, the continuity or similarity. In the discontinuity, edge based. In the continuity, three types are there. So that is the threshold, and it is a special theory. So it is not an important thing. So based on this one, region based segmentation, a region can be classified as a group of connected pixels exhibiting similar properties. The similarity between pixels can be in terms of intensity, color, etc. In this type of segmentation, some predefined rules are present which had to be obeyed by a pixel in order to be classified into similar pixel regions. Region based segmentation methods are preferred over edge based segmentation methods in ease of noise image. So region based techniques in further classified into two types, region growing and region splitting. So these are the very important. So in the when we are going for the region based, a region can be classified a region can be classified as a group of connected pixels exhibiting similar properties. The similarity between pixels can be terms of intensity, color, etc. In this type of segmentation, some predefined rules are present which have to be obeyed by a pixel in order to be classified into similar pixel regions. So region-based segmentation methods are preferred over edge-based segmentation methods in case of noise image. So when we are going for the region-based technique, there are classified as two types based on approaches: region growing method, region splitting, and merging method. First, we will go for the region growing. So region growing technique is a method to start the some pixels as a speed pixel and then check the adjacent pixels. If the adjacent pixel avoid by that predefined rules, then that pixel is added to the region of the seed pixel, and the following process continues till there is no similarity left. This method follows the bottom-up approach. In case of region growing, the preferred rules can be set as a threshold. For example, I am taking a seed pixel of 2 in the given image and the threshold value is 3. The pixel has a greater than the 3 will be considered inside the speed pixel regions. So region growing is a one type of technique in a region based segmentation. So in this case, the region growing method, we start with some pixel as a speed pixel and then check the adjacent pixel. If the adjacent pixel avoid the predefined rules, then that pixel is added to the region of the speed pixel, and the following process continues till there is no similarity left. The method is follows the bottom-up approach in the case of region-based, but rules can be started as a thresholding. If you are taking one example of pixel 2 is a given of image and the threshold value is 3. If a pixel has a value greater than 3, then it is going to be considered inside the seed pixel region. Okay, so otherwise it will be considered as another region. Hence, two regions are formed as following images based on a threshold value of 3. First one is a original image, that is the input image, and growing image processing of 2, it is the output image. So in the input image, if I'm taking the values of 1 2 3 1 2 0 like this, so it is the 6 by 6 matrix. Okay, so here I'm taking 2 by 2 into 4 by 4. Here 2 by 2 into 4 by 4. So R1 completely is a 2 by 2 matrix. 4 by 4 is completely I'm taking as a R2. So how we are splitted like this, but it will be considered as another region. Hence, two regions are formed for the following image based on this one. Thresholding of 3. Okay, it is a thresholding of 3. So here 1 2 3 1 2 0 1 1 2 0 like this. Okay, when a region growing process of 2 in a speed pixel, so I'm converting as a 2 separately and 4 separately. So this one I'm taking as a 2 value. Here this 2 belongs to the R1. Okay, why? Because splitting of image into 2 regions based on a threshold. Okay, it is a region 1 and it is a region 2. So it is converting to the region 1 and region 2. Region splitting and merging techniques. In region splitting, the whole image is first taken as a single region. If the region does not follow the predefined rules, then it is further divided into the multiple regions, usually 4 quadrants. Okay, when I'm taking the multiple regions, that is 4 quadrants. And other predefined rules and carried out of the regions of in order to decide whether further subdivided into classified, that is regions. The following process continues till there is no further division of regions required in every region follows the predefined rules. So already in the region growing is a first type we have discussed. Another is a region splitting. It is a second type. So in the region splitting, the region splitting has a whose image is first taken as a single region, and the region does not follow the predefined rules, that is further divided into 4 multiple regions, 4 quadrants, and the predefined rules are carried out in those of regions in order to decide whether further subdivided into classified that has a 4 regions. But the following process continues till there is no further division of regions required, that is every region follows the predefined rules. So in region merging technique, we consider every pixel as an individual region. We select a region as a seed region to check if adjacent regions are similar based on predefined rules. If there are similar, we merge them into a single region and move ahead in order to build the segment regions of the whole image. But the regions splitting into the region merging are alternative process. Usually first region splitting is done on an image, so as to split an image into maximum regions, and then these regions are merged in order to form a good segment image of the original image. So in the region merging, the technique, we consider every pixel as an individual region. So I'm taking as a every pixel. So this every pixel is an individual pixel. The region and a speed region, it checks adjacent regions are similar based on predefined rules. But in the when we are going for the similarity, we merge them into a single region and move ahead in order to build the segmented regions of the whole image. Both region splitting and region merging are iteratively processes. Usually first region splitting is done by on the image has to split an image into maximum regions, but the regions are merged in order to form a good segmented image of the images. Okay, so if we are merging the merging multiple images, what will happen? It is a original image. So when we are going for the multiple regions, in case of region splitting, the following conditions can be checked in order to decide whether to subdivide a region or not. If the absolute value of the difference of the maximum and maximum pixel intensities in a region is less than or equal to a threshold value decided by the user, then the region doesn't require further splitting. Okay, when we in casing of a region splitting, the following conditions can be checked in order to decide whether to subdivide into regions. Okay, so when we are subdividing as a regions, okay, so when we are subdividing a region or not, the absolute value of the difference of the maximum and minimum pixel, maximum and minimum pixel intensities in a region is less than or equal to a threshold value decided by the user, then the region does not require the further splitting. So when we are going for the thresholding, the value is in between the 2 and 3, 2 or 3. So it is a thresholding value when I am taking as a 2, otherwise I am taking as a thresholding value is a 3 value. Okay, so this splitting of the condition of checked deciding the whether the subdividing into a regions, but the absolute value of the difference of the maximum and minimum pixel institutes a region is less than or equal to a threshold value decided by a user for the region does not require further splitting. And it is one example of image, original image, that is the input image. So region splitting into 4 quadrants. So 4 quadrants. These 4 quadrants classify a quadrant as a region if it satisfies condition else performing further splitting. Okay, so we can observe here I'm taking the values of 1 1 5 6 2 1 6 7 3 2 7 4 1 0 5 6. Okay, this I'm dividing as a here 2 and other 2. So it is a 4 quadrant. So in this 4 quadrant 1 2 3 1 1 1 2 0 5 6 7 5 6 7 4 4 is there. It is a 4 by 4 quadrant. It is a region splitting. Why? Because I'm converting in the regions. Okay, first region. It is a region 1 and it is a region 2. So two regions with 4 quadrants. 4 quadrants. Here I'm taking the 4 quadrants. White color is one quadrant. This color is another one. Green is another color. 4 is there. So 4 different quadrants. Classifying a quadrant as a region if it satisfies the condition else performing further splitting. Okay, here only I am dividing as a regions. So input, then two regions, then output is a 4 quadrants. So input with the 2 regions for 4 quadrants. Okay, it is a region based segmentation. So in this segmentation, we grow regions by recursively including the neighborhood pixels that are similar and connected to the seed pixel. We use similarity measures such as different in a gray levels for regions with homogeneous gray levels. We use connectivity to prevent connecting different parts of the image. There are two variants of region-based segmentations: top-down approach and a bottom-up approach. So when I'm going for the top-down approach, first, we need to define the predefined seed pixel. Either we can define all pixels as seed pixels randomly, the grow regions until all pixels in the image belongs to the region. But in the segmentation, we grow the regions by recursively including the neighboring pixels that are similar and connected to the seed pixels. We use similarity measures such as differences in grow levels for regions with homogeneous gray levels. We use connectivity to prevent connecting different parts of the image. There are two variants of region-based segmentations. Top-down approach, we need to define the predefined pixel. Either we can define a pixel, seed pixel, or randomly choose the pixel. But both the pixels until the pixel's image belongs to the regions. But another one is a bottom approach. Here top down, but here bottom up approach. To select a seed only from objects to interest, grow regions only if the similarity criteria is fulfilled. But when I'm going for the similarity measurements, similarity measures can be different types. For the grayscale image, the similarity measures can be different textures and other spatial properties, intensity differences within a region or distance between the mean value of the region. So if I'm going for the top-down approach. So in the top-down approach, it that can be defined in the pixels. The randomly choose the pixels growing region until all pixels are belongs to region. But in the bottom-up approach, select a seed only from objects to interest go regions only if the similarity criteria is fulfilled. But in the similarity measures can be different types. For the grayscale image, with the similarity measures can be different textures and other spatial properties in intensity difference within a region or the distance between mean value of the region. So region merging techniques. In the region merging techniques, we try to combine the regions that contain the single object and separate it from the background. There are many regions merging techniques such as waterhead algorithm, split and bridge algorithms are there. But region merging technique is a very important role in the region based segmentation. But here we try to combine the regions that contain a single object and separate from a background. There are many regions merging techniques such as waterhead algorithm and split and merge algorithm. But what are the pros are there? It performs simple thresholding calculation. It is faster to perform, but region-based segmentation works better when the object and backgrounds have high contrast. So, what are the pros? Since it performs simple thresholding calculation and it is faster to perform. Region-based segmentation works better when the object and background have high contrast. Okay. So what are the limitations are there? It didn't produce many accurate segmentation results when there are no significant differences between pixel values of the object and the background. But in the implementation purpose, in this implementation, we will performing edge and region based segmentation. We will using skit image model for that and an image from its dataset provided. So if does not produce many accurate segmentation results when there are no significant differences between pixel values and the object of the background. So when I'm going for the foreground and the background, this pixel value of the background, so the background between the pixels and the foreground is a object. So it does not produce many accurate segmentation results when there are no significant differences between pixel values of the object and the background. But what is the implementation? This implementation we will be performing edge and region based segmentation. We will be using skit image model for that and an image from its data set provided. It is a implementation. Okay, in this implementation, in the region based segmentation, it is performing edge and region based segmentation and using the image model that an image from its dataset provided. So clustering based segmentation. Clustering is a type of unsupervised matching learning algorithm. It is highly used for the segmentation of images. One of the most dominant clustering based algorithm used for segmentation is k-means clustering. This type of clustering can be used to make segments in a colored image, and k-means clustering is a two-dimensional data set for better visualization, and the data set centroids are first randomly initiated, then the distance of the all points to the cluster is calculated and the points is assigned to the cluster with the least distance. Okay, clustering based segmentation, k-means segmentation. Clustering means we are adding some more images, more than one image, that the clustering. It is a type of unsupervised machine learning algorithm. It is highly used for segmentation of images. One of the most dominant clustering based algorithm is used for segmentation of k-means clustering. Okay, k-means means we'll discuss now. And this type of clustering can be used to make segments in a colored image. And k-means clustered is a two-dimensional data set for better visualization. And the data set centroids chosen for the user are first randomly initialized. Then the distance of all the points to all the clusters is calculated and the points is assigned to the cluster with the least distance. So then centroids of all the clusters are recalculated by taking the mean of that cluster as a centroid. Then again data points are assigned to the clusters, and the process continues till the algorithm converges to a good solution. Usually the algorithm takes a very small number of iterations to converge to a solution, and does not bounce that one. So okay, so when we are going for the centroid of that one, so this centroid clusters are recalculated by taking the mean that of a cluster centroid. Then the data can be assigned to those clusters, and the process continues till the algorithm converges to a good solution. But algorithms takes a very small number of iterations to converge a solution, and that is not a bounce that one. So image segmentation is one of the image analysis method to use to subdivide of an image into regions or objects depending on the type of shapes and objects searched for it. But image segmentation is an essential step, is most automatic pictorial pattern of recognition. And what are the applications of image segmentation is that it is an electronic board for missing components or broken connections, detecting faces, facial features and other objects for surveillance, detecting certain cellular objects in biomedical images, and these are the references for that one. So once we will discuss the region based segmentations. So region based segmentation consists of partitioning an image into regions that are similar according to a certain set of criteria. But the region based segmentation techniques involves an algorithm making segments by dividing into an image into various components that have similar pixel characteristics. But this technique searches for small and big chunks in an input image for the segmentation purposes, but it will either add more pixels to the selected chunks or further diminishes chunk points into a smaller pixels and merge with the other smaller chunk points. So therefore two or more basic techniques based on this method is a region based growing and a region merging is there. So when you are going for the region growing and region merging, we will discuss here. Gray color or black and white image is converting into the color image with the segmentations. But here, actually, image segmentation techniques are three types: edge-based technique, region-based technique, threshold technique. So, majorly segmentation techniques are based on discontinuity and based on similarity. So, based on discontinuity, edge-based technique, thresholding, edge-based technique. Based on similarity, thresholding, region-based, and spatial theory. In the spatial theory, neural network, clustering-based, and wavelet-based. But in the region-based segmentation, it is classified as a group of connected pixels exhibiting similar properties. The similarity between pixels can be in terms of intensity and color. But this type of segmentation, some predefined rules are present, which have to be obeyed pixels in order to be classified into similar pixel regions. But region-based segmentation methods are preferred over the edge-based segmentation methods in case of noisy image. Okay, so when it is a noise image, filters can be used. So region based techniques are two different approaches: region growing and region splitting or merging. So region growing, in this case of region growing method, we start with some pixel as a seed pixel and then check the adjacent pixels. The adjacent pixel avoid the predefined rules, then that of pixel is added to the region of the seed pixel, and the following process continues till there is no similarity left. But this means method of following bottom up approach. In case of a region growing, the predefined rules can be set as a thresholding. Okay, when you are going for the threshold levels, what are the thresholds level? If we are taking as a 2 or 3, but it is a seed pixel of 2 in the image, and a thresholding level is 3 of a pixel has a value greater than 3, then it will be considered as a inside the seed pixel regions. But in the otherwise, it will be considered as a another region. Hence, two regions is formed in the following image based on the threshold value. Here I am taking the input value. Here I am taking the regions. Here converting to the regions with region 1 and region 2. But in the region splitting merging technique, it is whole image first taken as a single region. If the region does not follow the predefined rules, then it is further divided into multiple regions or four quadrants, and then predefined rules can be carried out of those regions or to order to decide whether the further divided into classify that are regions. But the following process continues till there is no further dividing of the regions required for the every region to the predefined regions. But in the region merging technique, we consider every pixel as an individual region. Okay, every pixel as an individual. But the similarity of the merge them into a single region and move ahead in order to build the segmented regions of the whole image. The both region splitting of the images merging as a iterative processes. Usually, first region splitting is done on the image, so it is to split an image into a maximum regions, and the other these regions are to be merged in order to form a good segment image of the original image. But in the case of region splitting, the following conditions can be checked in order to decide whether the subdivided into a region or absolute value of the difference of the maximum and the minimum pixel intensities region less than or equal to a thresholding value divided by the decided by the user. Then the region does not require the further splitting. But these region splittings are the based on the original image. Region splitting into four quadrants. So input image, region splitting into four quadrants, classifying a quadrant as a region and satisfy the condition as a else performing further splitting. But here every region, input image, two regions and four quadrants. Okay, so in the segmentation, we grow regions by recursively including their neighboring pixel that are similar and connected to the seed pixel. We use similarity measurements such as differences in gray level of regions with homogeneous gray levels. We use connectivity to prevent connecting differences part of the image. There are two variants of region-based segmentations, top-down and bottom-up approach. In the top-down approach, we need to define the pre-defined seed pixel. Either we can define all pixels as speed pixel or randomly choosing pixel, grow regions until the pixels in the image belonging to the region. So top down and bottom up. So top down approach need to define the predefined seed pixel. Either can be defined as a pixel seed pixel randomly, and bottom up approach select only the objects interest grow regions of the only similarity of the criteria is fulfilled. But what is the similarity measurements? Similarity measures can be different types for the grayscale image, and the similarity measures can be different textures and other spatial properties. The intensity differences within a region of the distance between mean value of the region. But in the region merging technique, we try to combine the regions that contain the single object and separate it from the background. There are many regions merging techniques such as watershed algorithm, split and merge algorithms. Process since it performs simple thresholding calculation and it is faster to perform. But in the region-based segmentation works better when the object and the background have high contrast. And what are the limitations of that one is it is produce many accurate segmentation results when there are no significant differences between pixel value of the object and the background. But what are the implementation is that means the implementation will performing edge and region based segmentation. We will be using image module that for the image of a suitable image for its dataset provided. And clustering based image segmentation is a type of unsupervised machine learning algorithm and it is highly used for segmentation of images. Okay, but in the dominant clustering based algorithm used for segmentation in k-means clustering. But clustering can be used to make segments in a colored images. But when we are going for the two-dimensional data set, two-dimensional dataset for a better visualization. First in the dataset quadrant, choose by the user, and the first to randomly initialized. But when we are going for the distance of the points, all the clusters are calculating, and the points is assigned to the cluster with the least distance. And the centroids of all the clusters are recalculated by the taking the mean of that cluster as the centroid. The data points are assigned to those clusters, and the process continues till the algorithm converges to a good solution. But when we are going for the small number of iterations, due to this coverage to solutions does not the bounds. Okay, and image segmentation is one of the image analysis method used to subdivide into any image into regions or objects depending on the type of shapes and objects searched for its of the image. The image segmentation is an essential first step in most automatical pictorial pattern recognition and scene analysis system. But what are the applications are there? The applications of the image segmentation as a electronic board for missing components. So when I'm going for the electronic components are there, okay, some ICs are there, okay, and some screws or ICs are there. Suppose number of ICs. So how many number of ICs are there? So this inspecting the image of electronic boards are missing components, broken connections. Suppose here 10 components are there. So when I'm going for the image segmentation, 10 are showing. If anything broken or anything is there, if it is showing as a 9, okay, definitely where is 1? Okay, it is showing as an electronic board, the missing components are broken connections. But detecting faces, facial features, and other objects are surveillances. But detecting certain cellular objects in a biomedical image is also an important. So these are the main things of region-based segmentation. This is one example of grayscale to color image. And these are the major things of image segmentation: edge-based, region-based, and thresholding. In the segmentation based on discontinuity and based on similarity, edge-based, thresholding-based, region-based, and spatial theory. And these are under neural network, clustering-based, and wavelet-based. In the region-based segment, region growing and region splitting. In the region growing technique, it is a thresholding level of 2 or 3. It is one example of original image with regions and segmentations. So we are splitting image into regions. So region splitting and merging are the first taken as a single region. Okay, we're taking as a single region, converting into the multiple regions of 4 quadrants and subdivided into the classifying as a region. The following process continues to further division of a required regions following the predefined rules. But in region merging techniques, we are taking as a building a segment regions into multiple or whole region. So in this case of region splitting, the following conditions can be checked in order to decide whether to decide to subdivide into regions or not. And the absolute value is different of maximum and minimum iterations. And it is the original image with 4 by 4 quadrant. It is the 2 region, and it is a 4 quadrant. Okay, this is the 2 by 2, 2 by 2, 2 by 2, and it is a 2 by 2. Okay, so total 4 quadrants. So it is a classifying a quadrant as a region of a static condition and else performing for further splitting. Okay, top down approach and bottom up approach, and what are the similarities of the measurements, and region merging technique, pros, limitations, and what are the implementations. In these implementations, so edge-based segmentation and region-based segmentations discussed here. Here, cluster-based segmentation is there. In this cluster-based, we are using k-means algorithm. But this k-means clustering is a two-dimensional. Okay, any of the image with two-dimensional. Okay, it is a two-dimensional data set for better visualization. and it is a dataset centroids of the first randomly initialized, and the distance of all the points to all the clusters is calculated, and the points are assigned in the cluster with the least distance, and the centroids of all the clusters are recalculated by taking the mean of that cluster as a centroid, but the data points are assigned to those clusters, and the process continues till the algorithm converges to a good solution. But algorithms takes a very small number of iterations to converge to a solution, and does not bounce this one. And image segmentation, and what are the applications are there? It is analysis used to subdivide into a regions. Okay, subdivide the regions, subdividing into the regions, and the shapes and objects search for its image. But image segmentation is an essential first step in most automatic vectorial pattern recognition of the scene analysis. What are the applications are means inspecting images of electronic boards. So when I'm using the electronic boards, how many components, how many electronic chips are there? It will be testing, and what are the broken or what are the missing components? It will be detecting, and also detecting faces and facial features of other objects, and detecting certain cellular objects and biomedical images. Okay, thank you.
Like, share, and subscribe. Hit the bell icon for more updates.